Hello, this is Mr. Taylor with Young Engineers Today. This is a recap of our webinar on part 2 of EV3 from Monday, September 22nd. All right, we had a lot of questions during the lab about the lab as well as the webinar and how to install the software. So we're going to start off there. You have to use this link, and when you go to the link, you will get this screen, which will give you the option between OS X, which is a Mac software, and Win32 is Windows. Then you'll click on the link below it. The thing that's great about this software is that it will automatically choose the correct one for your computer, for your device. After you do that, the second screen, after you click on that link, you will click on download, and then it will download. Okay? Alright, then we reviewed the lobby, just making sure that like 2 is where we add programs, 1 is the lobby, you have your quick start, your news, more robots, and what you've opened recently. Alright. And as we said, we just reviewed this section during the webinar. Then, following that, we went back over the different blocks in programming. If you remember from the previous class, we went over action blocks, which these are basically our motors, some of our display, as well as our sound and brick status lights that you can control. Then we went over flow control. Under flow control, you have the start, wait, loop, switch, and loop interrupt. Alright, and I'm actually going to pull up my software, and I'm actually going to show you each one of these. Okay. Now, as it's loading, go back to the presentation. The wait is more powerful than just a wait. It actually gives you access to all the sensors, which does wait until a sensor is activated. And let's add a program here, and we'll actually look at these blocks. Go over to the orange. Now it starts out with the play button. You might be wondering, why do I have the play button or the start? In case you delete it or you're going to run 2 programs simultaneously. Now, when we look at, first I'm going to make sure it's hooked. You have all the sensors that you can interact with. So color, brick buttons, timer, motion, touch. Now, and then within this you can do compare or change, and that's with all the sensors. Compare, looking at greater than, less than. Change, is there a change based off a start value. Then we have our loop. Now the thing about the loop, you can do by count, which is a number of times. You can set up logic, which for advanced programming you do time, or you can leave it on forever, or you can have it activated by a sensor. So if I do a color sensor, we'll just do color, you'll notice now the loop will continue until I set up a threshold, or it sees a certain color. Okay. The next block we discussed was a switch block. A switch block, very similar. It gives us an option on what it wants to do. So typically you use this with a sensor. If the sensor is activated, it either is going. If it's not activated, it will do one or the other. Okay. So now, if we want this step, like where we have a line following robot, we would actually put this inside of our loop. You can use your arrow keys to scroll up and down or left to right. This allows my robot to make the same decision over and over. Unlimited meets forever. Then our last one was interrupt. A loop interrupt is like a kill switch. Kill switch is typically on like heavy industrial equipment. It's a safety switch where it doesn't matter if it's programmed, it will shut it down. The thing about the loop is whatever code is before the end of the loop, it won't react till everything is ran through the loop process. So if you put one of these in, it helps cause an interrupt. Okay? All right. Now, the next set of sensors we went over were the sensors. I should have said next set of blocks, but next set of sensors. And actually, you don't have as many compared to the in the home edition compared to the educator edition. But the thing that's great about the software, if you hook up any sensors, it will recognize it. So, for example, I can even hook up the old NXTs and it will recognize them. Okay. Here you have brick buttons, color sensors, infrared, motor rotation, which motor rotation allows us to calculate how many rotations our motor does, timer, as well as touch sensor. Okay. And during the lab, or excuse me, during the webinar, we actually took time out and had the students got to explore these. So I recommend you going through and seeing all the special features of each one of these. Okay. Next, we went to data operation blocks. These are for more advanced programming, mathematical data collection, where, for example, my 8th grade students last year did a project where they basically went into a cave with the robot. I made the cave out of boxes, but the robot would start at the front, go a little bit into the box, and there was a series of 2 boxes. So the light would get would decrease the further you went in. So by a little bit into it, it would take a reading, then would go all the way to the back, take another reading. What it did was it would automatically do a calculation which would take the average of the overall light from the front to the back. So you could actually bring that out. And they actually have robots that do this where they'll go down and they'll collect data and then bring it back for us. But this robot was to the point where the kids actually are making it do all the calculations for you. So once again, in the software, you have the red, and you can actually see what these do, experiment with all of them, and once again, all you do is you just pull them out, and with variables, you have to read or write them, and there's a lot in there, but we're not going to be going into any advanced program, so if you want to delete that, you can go ahead and hit delete. Then we have our advanced blocks. We have file access, messaging, Bluetooth connection, keep awake, raw sensor values. A lot of this is used with some of the scientific sensors, as well as other aspects that's beyond just building robots, as I do air quotes that anyone can see. And then my blocks. The thing that's really cool about my blocks, we'll look over here. So you can see all these messages. Here's the message block. You can send, receive. You have my blocks are for making a program that you use a lot into a personal block. So let's say you have, once again, have a line following front. It's a very common program. You don't want to keep rewriting it. You could make it its own block, okay? Which is really cool. And then it saves time and it actually shows up in the My Blocks section. Then we started going over some the motor features. With the servos, you have to go positive or negative. You go negative, they go backwards. You go positive, they go forward. Then we went over the move steering block, which you can do brake or coast. Brake comes in an automatic stop, which most of you use in the lab. Coast is a rolling stop. And the different ways you can program these move blocks. What I want you to notice for the steering compared to the tank, the steering, when you control one, the motors are controlled with the same same set of instructions. Where the tank, you're going to have to program each side individually within that block. Now, we talked about that in the webinar, not using seconds. And as someone in the 730, I think it was Chloe, give a great example, was with seconds. If you're using seconds and you change the power, how fast the robot moves, and you have it on for 5 seconds, if you have it on for A power of 5 for 5 seconds is not going to go very far versus having on for 100 power versus 5 seconds, which was a great example by Chloe. Then we have the move tank block, and this is where I was discussing the difference. If you want both you can turn one motor. If you wanted to go in a circle, you would slow this one down. If you wanted to make a left, you would make this motor go backwards and this motor go forwards. And it actually does the inverse, and you can actually type negatives. This would create the robot to do a different type of turn, which we'll show momentarily. Then a large motor block, I want to point out to you, is you can only control one motor at a time here. Then you have the medium motor block, which is specifically made for this motor. And once again, it's only one, so you're only controlling one of them at a time. And you can always change the port. Here's the proper ways to do some programming. The one I want to point out is we recommend using the download button, not the play button, because if you are going to have your robot move further than the cord length, what it does, it can cause damage to the robot's port where the US micro port is plugged in. You can cause USB connector on your computer. You can cause damage to the cord, and we don't want to do that. All right. So it's better to be safe. Use safe practice here. Now, here's the difference in turning, where this is what I was talking about with the move tank, where you can see this one's on 0 and this is 50. This is how your steering one would move. If I move right, this is called a pivot turn, kind of like a basketball player, where the one wheel won't move and the other will just turn. So this is a swinging type motion, so also known as a swing turn. The one below is it's going to move in the same spot, and what this does is one motor goes forward, the other goes backwards, shown by the arrows pointing, and this is a point turn which moves around their center of gravity, okay? Which is a really cool feature. Once again, here's looking at the way this is turning. As you can see, this was off and this is going and this is switching around. It's another way of looking at it. And then we talked about math. We can use math to make our distances more accurate. I know a lot of students in Raleigh and some of the students in Hickory, and I assume some of them tonight in Charlotte. We're using the pointer on the tire, and we're actually rotating the tire during the sumo, getting prepared for the sumo bots. That tire would turn, and they would count how many rotations. So, and this is the same type of way of doing it. If I know one rotation equals 10 inches, because I multiplied the pi times diameter, that would give me the inches. Now, if I wanted to go 85 inches, I know that I can divide 85 times 10, get 8.5, and that's how many rotations I type in. And you can do this with any wheel. And you can also do it with turning, which is a great feature too, okay? Now, the last thing that we did during class, students explored this. We also checked out these 3 videos. One is sumo bot example. Sumo bots are all over. We did this in the lab. The second one was a video about just EV3 and the different robots the EV3 Home Edition recommends you building and shows you code for that you can download that we looked at in the lobby. And then the last one is the stair climbing robot that I told you last Wednesday about, that I was going to show a video in class of. All right, this is a recap of Monday, September 22nd's webinar. Thank you and have a great day.